All right. You see that?
Yeah, sure.
All right. So Fiesta and how it works. So first, I'm just gonna do. I should probably put this up here.
I'm not gonna see the window.
Can you see this?
No, it's only that like small screen.
You can only see this.
Yeah.
Try this again. So it should be, yeah.
And now, and yeah,
What can you see? All right, perfect. Okay, so this is just the whole video. 83 picomolar K560 GFP, 6.9 pH. Going to do this. Okay, so here's our video. Have a couple microtubules on there. But to actually see locations, gonna do my Z projection. And those are the microtubules. Okay, so now gonna open up Fiesta. I just did this just so I can see where the microtubules are. My poor computer. Seconds trying. There it is. All right, so then this is Fiesta. So first thing, we're gonna go to data, open stack. Going to select whichever video you want to analyze. I think it's this one, yeah. Oh, okay, yeah. So I've never actually, never done Fiesta on Kinesis, so I might take some of your parameters actually. So the time difference in milliseconds, this is at 10 frames per second. So I forget, do you know the transfer rate in the Nikon?
Nikon, I think we just neglect the light time.
It's the same.
Yeah,
We don't need to add anything to the
yeah.
exposure time.
Talking about this plane time difference is this usually 1.2
Yeah, I think that's what I use too.
We add two things. One is pixel and one is I think this.
Yeah, time, yeah. It is a specific specify the time and pixel size.
Yeah.
Exposure 1.1. Per joule.
Wait, what? Two. Okay, so mine will be one. This is since
Yeah,
it's
could
at
be
10
like 1
frames per
millisecond,
second.
yeah,
So then,
maybe, yeah.
yeah, wait, hold on. Let me. Why did this? Okay. Let me just double check with. Yeah, so 10 frames per second. 101.18 milliseconds. So 1.18.
Exact value.
Yeah, so the 1.18 milliseconds is for the transfer of frames. The pixel size is 58 nanometers on the Nikon. And then this is our video. So first thing you have to do is make it binary. So hit this little white circle, black circle up there. Now everything will go black and white. This bar is to actually change the thresholding. So you can kind of move that a little bit till you see your enzymes. So the trick with this is you want it bright enough to see all your enzymes still, but you don't want it too much where you have all this like noise, because that's just going to make the analysis really long for Fiesta. So Can run through it, make sure all of our enzymes are there. To double check, we can go back to the normal picture and see if the enzymes line up. So there's a couple here, go back and they're still there. So it's a decent threshold for right now. Next, since you don't want it to analyze the entire area, you can go to this little tool right here and then select which areas you want to measure. So this is, I'm gonna look back at here to make sure I'm circling the right areas. So it should be roughly here, we'll say, for this microtubule over here. Just to make sure, I'm going to go through the whole video, make sure everything that's moving on the microtubule is in that area. And it looks fine. So you can also circle all of the microtubules to do the entire thing at once. Like up here too. I'm gonna try it and hope my computer doesn't. Actually, I'm not gonna do it because I don't want to wait the 10 minutes for this to analyze. So these are your regions down here. So in case you have a region that you don't want to use, you can go down to here, left click, and then delete. You'll still have your other regions. You want to make sure if you're circling areas of the microtubule that you want to analyze, you want to make sure that this box is not checked. Because if it is checked, then it will measure everything but the area that you circled. So we'll have that. And then just go to check configuration. This is where all of your actual parameters will go. So the pixel size 58, frame or time difference is 101.18, which we inputted before. Your first frame, last frame, so which frames you actually want to measure. This is 1,000 frame video, so we're just going to do all 1,000 frames. We're only looking at molecules, the GFP labeled kinesin, so we're going to circle or click only molecules. The filament tracker in this isn't great, so I don't really recommend using it. Going to keep average before and everything in here, basically keep that the same. Down here for the max velocity, I'm going to increase this a little bit to 1100. So this, if you have a kinesin moving faster than this, it won't track it. It'll just kind of delete that trace, or at least up until the point that it starts to move at that velocity. So make that 1100 nanometers per second. The weights are, so this is for keeping it one track, right?
Yeah, so after your file is stored, if you connect, and once you analyze, you will see like connecting the checks. That's what this range effect.
Right.
Effect.
Yeah, so most of the time the defaults work relatively well. But if it starts to like in this video, we can see that sometimes the point spread functions overlap, like right here. So if that is a big issue, you might want to increase your position weight, because the speed and direction are going to be the same anyway. So that won't really, if you have two enzymes moving at the same speed, same direction, it'll just get confused unless you specify you want to focus on the position. Then it'll separate out those two. For the minimum length, that's going to be how many frames are required to make a trace. So for this, I'm just set 20. So it has to be moving for 2 seconds for it to actually make a trace. The maximum break is the time that so in this case, it's GFP. So basically the time that the GFP can go dark before it will end that trace. So if I have this at 10 and the GFP goes dark for 5 frames and then comes back, it will still count that as one trace. So to kind of remove some error, because if you have one that's moving and unbinds, another one binds close to that area, and within 10 frames, it's just going to think that's all one molecule. So in this case, I'm just going to set that to 5. Maximum angle is the angle that your enzyme can turn before it starts a new trace. So for this, I'm just going to do 360 because we want to make sure it really shouldn't change direction, but just in case the software kind of gets confused, we'll just set that to 360 for now. You want to keep 2D Gaussian fit, which here it's applying a 2D Gaussian fit to your point spread function. And then it will take that middle point as its actual position. And it will then do that for each frame. So for like this, it would do a 2D Gaussian for that, find its true position. If we go to the next frame, it'll realize that's the same molecule, another fit, and then it'll just make the trace that way. And that's pretty much it for this, right?
Yeah.
So yeah, I'm going to do apply. Then after you set everything up, it's still in binary, and you have your areas selected. Then you can go to add stack to local queue. It will put it up here. To actually analyze it, you'll do analyze local queue. I already did this analysis just to save time. So normally you would hit this, you'll see a little text box come up and it will tell you which frame you're on, how many particles it's tracking at that time, and just the general percent of how close it is to being done analyzing the video. So once you do that, it will go through every frame, measure all the positions for the enzymes. It will then, another window will pop up where it connects all the frames between, or connects all the traces between the frames. And then it will just go away and you'll just be stuck at this screen again. So to get your traces on the screen, I'm just going to maximize this now. So you go to data, load tracks, which is the one that I want. It will come up as your file name with just a bunch of numbers afterwards and then be .map. So you'll select the one that it just made, go to open, and then these are all your traces. So to look at the actual molecules, go over here, hit data, and these are all the molecules it tracked. So to actually look at them, you can then hit this little side window, and it should bring up XY positions. So these are going to be all of your kinesins along the microtubule. You can go through them and just kind of make sure, like this one looks like it stopped, or the tracking software just kind of got messed up. So you probably want to delete that or just exclude it from your analysis. This is not processive behavior, so I'm going to delete that.
We can delete in between things also.
Oh, like to delete points, I mean, yeah, so you can select which ones if you want to, like, if like that doesn't look, actually here, let's go to like up here. So like, let's say this was a really good looking trace, it just paused it at the start. For your velocity and stuff, you can delete this. Just highlight them and then just go delete points and it will get rid of them. That is going to throw off your binding time though, so I don't know if I would recommend doing that. But yeah, so for like here, there's a gap. You can try to do track missing frames, which will hopefully oh man. Ooh, how long is this going to take?
Can you recover the data you deleted?
Yeah, so it will always, you can basically just open up the file, like the same file that you originally opened up, because when you delete it, it's not going to overwrite.
Oh,
Yeah,
So
yeah.
I suggest that you once you delete or modify to like anything, then you save as a different file.
Mm.
So
Right.
you have to roll and modify them.
Right. So track missing frame, it really, I probably wouldn't use this because it's not really reliable, and plus
Yeah.
you're kind of just adding to your data, which isn't really what you want to do. But for like here, again, not processive, so we'll delete that. And yeah. So then once you have all of your molecules here, so let's let's
There's something like in the window, let's change small window.
oh
Yeah,
right
here's the
right right
X, Y, and you can.
yeah, so you can change the plot that you want to do, so you can go time versus distance. So here are your actual time versus distance plots. Oh, that one paused. That's interesting. You can go, yeah, you can kind of just mess around with this. You can go distance from origin to whatever you really your heart desires. You can also do histograms in here to see your distribution of velocities. Wow, that is as a distribution for sure. What else? If you want to select specific points, so let me go back to time versus distance. You can, instead of clicking here, you can also just do it down here for extra accuracy. I guess you can export the plot that you make here using that. Anything else is pretty much, yeah. So for most of the time for Kinesin videos, you're going to be using a high frame rate. So your actual video length won't be that long. But for you, since you're doing really long videos, if you have drift in your actual video, what you can do is go up to here. Oh, wait, no, let's see here. Oh, you can go to edit and then find best reference molecule. So if you do this, you're going to want, if you have like a fiduciary marker on your surface that isn't going to move. So let's see if there is one in this video. Not looking like it, but let's, like, if you add like tetraspec beads, or if you're using like an IRM video and there's something on the surface that won't move throughout the entire video, what you can do is just circle that and then include that in your tracking. And so that will just basically be used to remove drift correction. So if you did that and you had a ton of fiduciary markers on the surface, you can then go to edit, find best reference molecules, select how many you want. Recommend around 5. You can do, you'll say okay. Here it probably won't do anything because all these are basically moving. But it will go through, select your best reference molecules. Those will then be highlighted over here. So like, let's say like it was these couple, whatever it was. These will then be highlighted. You can then go to options, set as reference, and it will, I don't want to actually do it, but it will take all those position traces from those fiduciary markers, like the XY positions, and then subtract those for all of your molecules. So that's just an easy way to do drift correction then.
Also you need at least like 3 points to do the chip correction. So
Right.
you need like add a good amount of fiduciary marker in your sample.
Yeah. So yeah, right. Because for each molecule that you set as a fiduciary marker, it's going to average out all those positional changes. So if you only have like 1 or 2, and one of those has error in its positional change, when it goes to subtract that out, you're then adding error to all of your traces. So you really want to make sure, like when it selects which ones, you want to go through and make sure that they all have similar traces. so that it will be more accurate drift correction. Let's see here. So sometimes it can also split up. Sometimes it will get confused and basically make two traces for the same enzyme. Like it'll have half its run length in one trace, the other half in another one. If that does happen, you can just highlight those traces using this little tool up here, just highlight them or select them on this list. You can then go to edit and combine selected traces. So let's just do it for two random ones. It's not going to look great, but you get the idea. So let's say these two were the same molecule, but just split, and you checked by going into here and made sure it's the same molecule. Go to edit, join selected traces, and then you can combine them here. So if it says warning overlaying frames, it will circle those in red. Yeah. So then you can select all of those red points and do delete. Yeah, so I'm gonna do it here since I'm not actually using this data. So then it now will think this is all one trace. You can do OK, and now that's all combined into one. Obviously it looks terrible since those are two different enzymes, but you get the idea. See what else is there.
I think that's mostly.
When do we need drip correction? And I had a question for the kind of when we need to do drip correction.
Drift correction is most of the time if you're just taking really long videos. Like here, let me get like a cell 7 video. Got to bring cell 7 into this somehow.
So yeah, basically there are like two versions of drip correction. You have your version from Joe's code that do the drip correction on the movie. So you bring the movie back instead of analyze after we get the precision. So in this Fiesta, it's not modify the movie, it just change the result.
It's the same stuff.
No, it change the result in like the precision data. But you will have the same movie, right? So yeah.
Say like this, you see,
Oh, that's not.
the Joe's code.
Yeah,
will
it's not even
actually
drifting out.
correct The movie, the actual movie, let's see the same point here. Next, become like here, there's a, you can see the drip drag. Use Joe's code, you can actually put this together. You get a new movie with no drift.
Okay.
But with Fiesta, the movie is the same, you can still see the drift, but you have the correct data.
Okay.
They didn't correct the movie, they just correct the data. So if there's a drift, you see maybe like this, but after correction, data will be like this. You see the difference, just one is correct, the movie is correct data.
And the correction on the movie is in low resolution because each pixel is like 80 nanometer. And when you bring it back, the best you can have is
It's
1
1
pixel
pixel, yeah.
resolution. So if it drips within 80 nanometer, then that code is not working. But here, because we are checking molecules in nanometer precision, so it can correct like drip under 10 by nanometer. Yeah, that's
Right.
different.
So like this is 500 frame video at 1 frame per second, so 500 seconds total. If I go through it really quickly, you can see it moves a little bit. There's a little bit of drift there. What's up?
It's not dancing.
Oh yeah. Yeah, so if you see like how the entire frame, like even like the stuff on the surface is moving, then you can in Fiesta select those areas so that it will track that and then set those as your fiduciary markers, subtract out the drift from the XY position, And then all of the traces you have here will all be drift corrected. So let's say these are all drift corrected. You have all your molecules here. Everything's looking good. Then go to data, save all tracks, and set like whatever name you want to say, and then just do like drift corrected afterwards. Just so you know that that's your actual drift corrected file, and then you'll still have the raw data from when it originally tracked it. And then you can take these traces, put it into MATLAB or wherever, and do the rest of your analysis from there. Let's see. Guess you can get some statistics here. Oh, you have to do. So if you want to get like a rough estimate of your stuff, you can select all your enzymes, do statistics in Fiesta itself, and you get your little histograms.
Oh, it works.
Yeah, you can then go through and see. So the light blue is the actual molecule you're at. The dark blue is just the total population. You can go through and look at all your traces. Yeah, and then you have your velocity and time plot on the right. You can probably change that.
Let me use this.
Yeah, most of the time I just do it in MATLAB just because
Yeah.
I don't know how much I really trust this. I've never,
And it's like a black box. We don't know how it works, and
Yeah.
it could add data, it could delete data, and sometimes don't have control.
right. What does this do? I guess it's probably, yeah. You then fit the Gaussian fit to your actual data. My computer's really struggling. Okay. So if your computer isn't lagging behind, it
Yeah.
would, you could then do your Gaussian fits, but again, probably recommend just doing it in MATLAB anyway. Oh, so when you do your drift correction and go to set as reference, it will do its a little window will come up. It will subtract that XY position from all of them. I forgot, you then have to go to apply corrections. So then it will then do all the drift corrections for these. If I was drift corrected, you would be able to see the difference between checking and unchecking these. I guess you can also do it here. So since there's no drift, it's not going to change anything, but you would do it. So then you have to select this box, apply drift corrections, and then go to save all tracks. Yeah, and then for if you want to do a new video, you'll then just do clear all tracks, remove all of your regions. God, my computer's really struggling. And then just go up here, open stack, and select your next video that you wanted to do. And then you just go through all your videos. And at the end of it, you will have all of your trace files, and then import that into MATLAB since it is a .mat. Yeah, do your rest of analysis. That's basically, I feel like we're still missing something.
So maybe that check configuration window. There's something say minimum length and break. So the unit is in frame.
Oh, yeah. that's
Beware
true.
that if you change the frame rate, and then you need to relay this number to the real thing. So what I'm going to say
Right.
is like, if we know that a QDOC may blink and being in dark for like 5 seconds, and then this 5 seconds is set. So if
Right.
you change the frame rate, then you need to set this to make up like 5 seconds.
Right. So since this is
Yeah.
10 frames per second,
it's
that
10
would then be
frames.
50.
Yeah.
Yeah, that's a good point.
Yeah.
Yeah, so
And
like
also
this
the length
20
also something.
is, what'd you say?
Yeah, like the length is like I know it's like the minimum binding duration of your enzyme, let's say, and it's like at least 10 seconds. Again, we are talking about seconds because it's physical thing, it's not frame.
Mhm.
Then you need to calculate your frame based on your real time and your frame rate
Right.
and set it here.
Yeah, so if this is 10 frames per second and you know most of your stuff is going to be moving for 10 seconds, set that to 100. If anything moves for only 80 frames, it will not create a trace for it. So you won't have I already gave it all yeah. But yeah, you wouldn't have that show up in your molecules.
So this parameter is used to connect all those dots.
Right.
So like for IRM, we don't use any SOP or any like goal. What do you said for minimum?
In that case, if you don't expect any like break, you can just set it to 0. But
Mhm.
I would say set it to 1 is safe because
Yeah.
0 sometimes will cause software to crack. I don't know why, but
Right.
I don't like 0.
Especially in here, if your threshold isn't high enough, your molecule might disappear for a second.
Yeah, exactly.
So yeah, so like yeah, I don't know. 0 might be cutting it close, but yeah, 1 frame just to be safe. Yeah, these parameters you're gonna have to mess around with based on your data.
Yeah.
These two, and maybe if you're and definitely make sure your max velocity is faster than your enzymes are going, or else you're not gonna have any traces. And if you have a lot of like point spread functions of your stuff overlapping, you might want to mess around with these parameters as well. But for most cases, you can probably leave these as the default. And this you won't really have to change. Just 2D symmetric Gaussian. I don't know what these are. Parallel processing.
It's like for some computer, they have a lot of CPU,
Mhm.
and then you can use it to accelerate the analysis.
Gotcha. Okay.
But yeah, just so like we have a idea how long this would take. If we have like 1,000 molecules in one frame, and we have 1,000 frames, that would take like overnight, I would say.
Right. Yeah. It can go for like 6 hours.
Yeah.
Yeah. So yeah, you want to let it start
Yeah, let it
analyzing,
die,
go
go
to
to
sleep.
sleep.
Yep.
Always do that.
Yeah, exactly. So even for reference, so let's do this. Clear all traces. We want to do this microtubule, very rough estimates here. Just to get a point across. Yeah.
Based on your computer's performance.
Yeah, it's true. My computer is also slow. So like here, I have to extend that a little bit. So yeah, we have all of that. Check configuration, everything here is looking good. So yeah, I'll keep it I'll keep it at 1,000, even though, and no, it's not gonna like that. So 2 second minimum binding duration, half a second break. Keep that. Add stack to local queue. This is from earlier, so I'm going to delete that one. And analyze local queue. So all the time's going up. So even just for these 2 microtubules, it's going to take around 10 minutes. And this is really low. Like for our cell 7 stuff, it's at average probably 5 hours to do all of them.
Do one movie.
Yeah, because we also like with microtubules, you can select the microtubules because you know where it is. For cellulose, it's going to be entire area of cellulose. So yeah, in that case, it's basically trying to do the entire frame, and you'll have like 1,000 molecules per frame. So that is yeah. Also, when it's processing,
do nothing.
Yeah. you really don't want to cancel it because it's not going to like that. It's basically just going to crash your software. So I can try it here. And we got lucky. But most of the time, it will just crash everything. Maybe it's just because there's not a lot of objects, so it can do it. But yeah, this software is very easy to make mad. Wow, my computer is, yeah, it's giving its best leaf blower impression. Yeah, and also I don't recommend having multiple videos in the queue. Every time I've tried it, it will analyze your first video
Oh, yeah.
and then the
I
rest
also-
will just, yeah, they'll be corrupted files.
Yeah.
So you're gonna have to do one at a time as much as terrible as it is. But yeah, I mean, that's pretty much it. You got anything else?
I think that's it. I mean, like talking like if we look into this software in a bigger way, it's like just feed a dog with the point spread, and then we have a lot of dogs in the first frame and a lot of dogs in the second frame, and we set the parameters to tell the software which is the same molecule in this different frame, and by setting that parameter, it will connect all those dogs
Mhm.
and through the whole movie, and then it will give us checks of a lot of molecules. So, and then we basically use that checks, go into MATLAB and analyze it by ourselves because we know our data best than the software. It say
Right.
analyze the velocity histogram. I assuming it just, I don't know, assuming they just had a lot of data and put shit on that.
Yeah, so like what it's doing right now is it's literally just applying 2D Gaussian fits to everything.
Yeah.
It has no idea what is connected to what. It's just going frame by frame, applying fits.
Yeah, you say in for this frame, I find this number of objects. It say objects because they might have molecules or filaments. Maybe if you want to check the
For it,
probe.
what matters is on the intensity.
Yeah, the threshold is very important. Because if I lowered this and then had a ton of spots everywhere, it's then going to have like hundreds of objects found. But if your parameters are still pretty accurate in check figuration, it should remove a lot of those, but you're just going to have your processing time is going to be way longer. Yeah.
Yeah, basically, Zach said before, this is a binary image.
Mhm.
So this image tell the software, okay, look at a bright spot. This is like the start point. You want to fit the Gaussian, and you can set the threshold up and down. So,
Yeah. Also, did you check
What?
Did you check the mic on this?
check what?
My microphone? It is on. Right?
Yeah, it's on.
Okay.
I
Okay.
went out once.
That'd be tragic if it wasn't actually picking up
Yeah,
anything.
I went out once to check when it's on.
Okay. But yeah, okay, wait. So let's do this for a second. Oh, come on. Don't do this. Oh, okay. So just to get an idea of what it's gonna look like, I'm just gonna do the first 10 frames. So we're looking at 1 second. Actually, no, that's not gonna work because this is 20 frames. So we'll do 100. Add stack, analyze. Shoot. Which one? I think it's this one, right?
I would just delete all and then add
Yeah.
again.
Yeah, that is definitely the smart move. So yeah. Alrighty, all right. So yeah, so now it's gonna go through. Again, it's just doing positional changes right now. Give it that 45 seconds. But yeah, for the actual MATLAB analysis, probably gonna have to write your own. I mean, we might have some, might have,
We,
but if you're doing like a specific experiment,
exactly.
you're probably gonna have to, yeah.
So basically the file is, so it will give you frame and then, let's say this. So there's a table and we have a, molecular for a 2D table. And then we have X, Y in each frame. And the next frame, it goes to a different X, Y. And that's like the most information
Mhm.
from the Fiesta.
So yeah, that after that first window went away, the second one was combining all the traces. The third one is post-processing, so checking all the traces to your configuration. And then now it goes away and you're just gonna have to load it here. I think it's this one actually, yeah. And boom, there are your molecules.
Okay.
I think that's about it.
Yep.
Yeah, that's Fiesta. Now, how do we end the record? Okay.
So I have to play with it.